This is a discussion of balancing equations. As you know, balancing equations is not a difficult task. You just have to make sure you know the method that you need to employ to balance the equations, making sure the number of atoms of each element are the same in the reactant side and in the product side of an equation. The first question here you can see has 3 reactants and 3 products. And I specifically chose this one because it looks kind of difficult. Sometimes equations are pretty easy to balance and sometimes they're pretty difficult. So let's go through and figure out how to balance this one. Remember, there are several different methods to use to balance equations. But I think what I'm going to do is I'm going to do the list method of balancing for this one. So for this, I'm going to do my view, the inking, and I think I'll change to black. And so I'm going to list the different atoms that are on each side. So both sides have copper, sulfur, oxygen, hydrogen, and chlorine. And my job is going to be to first count up how many of each atom we have. So on the left side we have 2 coppers, looks like we have 1 sulfur, 2 oxygens, 1 hydrogen, and 1 chlorine. On the other side we have 1 copper, 2 chlorines, 4 hydrogens, 1 sulfur, and looks like 5 oxygens. Oxygen is usually something that's difficult to balance, so I'll try to balance that last. Alright, now I'm going to look around and I've noticed that copper is unbalanced. The good thing about copper is that copper has, it's only in one place on the left and one place on the right, so therefore it's pretty easy to make copper balance. Notice I'm crossing out and recounting. With this 2 here, it actually causes the quantity of chlorines to change to 4. Right, now I'm moving on. What else is unbalanced? Well, hydrogens are unbalanced, and that's a pretty easy one to balance too, because you can see that there's only one place hydrogen is over on this side. So if I put a 4 here, that would automatically make 4 hydrogens and 4 chlorines. So that's pretty helpful. So that helped hydrogen and chlorine. And I'm noticing oxygens. I really don't like oxygen because 2 oxygens are on the left and 5 are on the right, which isn't such a big problem, but whatever coefficient I put in front of the one on the left, it's never going to get to 5, because of course 5 is an odd number and 2 is an even number. So here's a trick. If you come to this place where everything balances except for 1, usually it's oxygen, try doubling. In other words, the coefficients that you already have down, in this case the 4 and the 2, try doubling those and see if that leads to a better answer. Now that's not going to be the full answer, but it might lead to the answer. So I'm going to erase these, and that means hydrogen is going, HCl is going to be 8, and copper chloride is going to be 4. Now initially it doesn't look like it helps at all, because of course here that means 8 hydrogens and 8 chlorines, which makes the whole situation worse. Although we do have 8 chlorines here, that makes 4 copper. Now let's see if that can lead us to the correct answer. On the left, I have to put a 2 here, because that's going to make 4 coppers, and the sulfur is also now 2. What else am I going to have to do? Well, I notice that sulfur is now unbalanced, so if I put a 2 here, that makes 2 sulfurs, and 2 times 2 is 4, plus 2 is 6 hydrogens. That's better, it's not good. And we have 8 and 1 is 9 oxygens. Another odd number. Quite unpleasant. Alright, so let's see what we can do. Now, we have 8 hydrogens on the left, and we have 4, 5, 6 on the right. If I put a 2 here, that makes 4 hydrogens and 4 more hydrogens, and that actually will make 8 hydrogens. You notice I didn't add to the previous number. I cross out and I recounted. So that helped hydrogens. And then let's check out oxygen. Over here we have 2 times 4 is 8, and 2 are 10 oxygens. Well, at least that's an even number. So the number we have to put over here is a 5, because 5 times 2 is 10. And if you'll take a quick scan, coppers are balanced, the sulfurs are balanced, the oxygens, hydrogens, and chlorines are balanced. So that's the equation. Sometimes when you're balancing equations and you put a coefficient down, sometimes the first coefficient you put down doesn't always balance it, and you have to go back and change it. That's the case here. So that's the balanced equation. Now, of course, this is a hard to balance equation, but it's pretty easy once you know the tricks. If you're doing a picture method, just keep going. Make sure the pictures match on both sides. Here's some other couple of questions. These are write the balanced chemical equations for the following. So, part A, nitrogen gas reacts with fluoride gas to produce nitrogen fluoride gas. So we're translating from words to symbols. Here's nitrogen gas. Remember, it's a diatomic. It reacts with fluoride gas, also a diatomic, to produce nitrogen trifluoride gas. Notice that's the prefix naming system. Trifluoride means 3 fluorines. It has nothing to do with the charge. Now we have to look at it, and we notice that it's unbalanced. So we now have to then go and balance this one. So what do I do? Well, I see that there's 2 fluorines here and 3 over here. I'm going to do this look and do method for me this time. So that means I have to get to 6. If I put a 3 here, that makes 6 fluorines, and if I put a 2 here, that makes 6 fluorines and 2 nitrogens. But notice we needed the 2 nitrogens, so that's actually the balanced equation. Now, the next question says, name the spectator ion or ions in the reaction. If there are no spectators, please indicate that by writing no spectators. Normally, we would break up the spectator, or we would break up the aqueous ions, or the aqueous compounds, into ions, and then we're going to cross out spectators. Notice we can't cross anything out, because nitrogen's a gas, fluorine is a gas, and so is nitrogen trifluoride. So therefore, this is actually no spectators. Let's look at this next set of questions. Write a balanced chemical equation for the following. Aqueous magnesium iodide. Now here this gives us an excellent review of writing compounds. We have Mg, I2. Magnesium is a +2, iodine is a -1, and so when we crisscross we get MgI2. Notice I'm putting AQ because the equation says aqueous. It reacts with aqueous tin 4 nitrate. So tin we know is a 4. I'll come over here and show you how to do that. And nitrate, which we have to memorize, is a -1. Of course, when we write the correct compound, NO3, we have to put the 4 outside, and it too is aqueous. And the products, as you can probably figure out, because you can notice this is a double replacement reaction, magnesium is going to end with nitrate and tin is going to go with iodine, but they've already given us the answers here, and they say it gives you magnesium nitrate, that's MgNO3 2, and tin 4 iodide, solid. Remember, for a double replacement reaction to work, a solid, liquid, or gas needs to be produced. And in fact, you can see that the tin 4 iodide is the solid that's produced. Now, it does say balanced in the directions, so that's exactly what I'm going to do. Now this time, I'm going to use pictures, because the first time I used the list method, the second time I balanced an equation, I just looked at it and was able to balance it with no problem. And this time I'm going to practice with the shapes. To do that, we're going to split it in half. And I'm going to do it like this. I'm going to say Mg is a square and I is a triangle, but I need 2 of them. Tin, let's make that a circle. And nitrates, I'm going to do 4 stars. And I can keep nitrate together because you notice nitrate appears as a reactant together and appears as a product together. That makes it much easier than having to break things up. Alright, on the other side I'm going to have square, star, star for magnesium nitrate, and tin iodide is circle and 4 triangles. Well, it looks like the stars aren't balanced, so I'll add another one immediately. And then what else can I add? Looks like I have to add more triangles to the left, so I have to add square, triangle, triangle. Let's see what I have. I have 2 squares, 2 squares, 4 stars, 4 stars, 4 triangles, 4 triangles, 1 circle, 1 circle. Okay, it's balanced. So this has 2 groups, 1 group of this, 2 groups of this, and 1 group of that. So that's a balanced equation. Remember, you don't really need to show your work for balancing, but if you have a list or a picture method, you're welcome to just leave it there. Now, the last thing we're going to do is write the net ionic equation for the above reaction. To do that, I'm going to show you how to write the ionic equation, just for practice. Every time we have something aqueous, remember we're going to break it into ions. So, magnesium iodide would look like this. And tin nitrate would look like this. Now you'll notice there's lots of buzzing noise in the background because I'm actually in duty and senior house. So sorry for the disruption and the crazy noise in the background. So those are the reactants. You'll also notice that I am not balancing the equation. There are 4 nitrates here, and I could put the coefficient in front, but I think it's easier not to, just because eventually they may cancel. And of course I can always balance later. I don't need to worry about it right now. Alright, magnesium nitrate gets broken up into its ions. And of course tin iodide, tin 4 iodide, stays together because it is a solid. I couldn't fit it carefully on the page, so that's why I put it down below. But it's really a product. Now, to write the net ionic equation, I'm going to cancel the things that remain the same on both sides. Sometimes it's easier not to put the coefficients, because if you don't put the coefficients correctly, you might not know which ones actually cancel. Nitrate goes away, as does magnesium. So the answer to this question is that which remains, which is iodine, ion, and tin plus 4 yields tin 4 iodide solid. Now I can balance it. In other words, I notice that there are 4 iodines on the right and only 1 on the left. So I will put the coefficient of 4 in front of iodine. For me, that's a lot easier than trying to balance it all along the way. I can just write the balanced equation at the very end.